Hello. So chapter 4 has a lot of applied problems. I thought I'd combine those ones together, like one from every section. So the first one, in 2010, Japan had a population of approximately 128 million people and a total of land about 150,000 square miles. What is the population density? Population per square mile is what your density is. Remember, per means to divide. So you take your number of people and divide by your square miles. Now, let's write these in scientific notation first. So 128 million, 1,000 million. So that would be 128 million. In scientific notation, we need to put the decimal here between the 1 and the 2 to make it a value between 1 and 10. Then we have times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 10 to the 8th. And this is the people. $150,000 would just be 3 extra zeros. Scientific notation, 1.5 times 10 to the 1, 2, 3, 4, 5. Now, we said for population density, we divide these. So we can go like this and divide. We divide them 1.28 divided by 1.5. We get 0.85 and then a 3 that repeats times 10. 8. When the bases are the same, you subtract the exponents. So 8 minus 5 is 3. So we have 10 to the 3rd. That means if we multiply this out, 3 decimal places larger. So it would be 853 people per square mile. So for every square mile, they have 853 people in Japan. In 2010, the U.S. population had 310 million. And a total land area of 3,720,000 square miles. What is their population density? So again, we'll write it in scientific notation, 3.1 times 10, 1, 2, 3, 4, 5, 6, 7, 8, again 10 to the 8th. 3.72 times 10 to the 1, 2, 3, 4, 5, 6. So we divide these. 3.1 divided by 3.72 is 0.833, keeps repeating. Oops, I'm putting in the wrong spot. Times 10 to that 8 minus 6 is 2. So it's 83 people per square mile. So in the United States, we have 83 people per square mile. When you're comparing the population densities We can tell that there's definitely a lot more people per square mile. You can also rate them as a proportion. If we put Japan on the top and the US on the bottom, it's approximately 10. Japan has 10 times as many people as the US per square mile. You could have also went the other way, and then it would have been 1/10. So the US has 1/10 of the population that Japan has per square mile. Either way is correct. The time, oops, no, we don't need this right now. The time it takes for one complete swing of a pendulum is called a period. And a pendulum can be like a clock, the chime that hangs. The period T in seconds of a swing pendulum is found using this formula. So let's put that down here. L over 32. T is in seconds, and this is the formula. Length of the pendulum, length is in feet. .32 is the acceleration from gravity. That's where the 32 comes from. And it's in feet per second. Find the period of the pendulum whose length is 2 feet 8 inches. Now the length is supposed to be in feet, so we have 2 feet 8 inches. We need to change inches to feet. Well, there's 12 inches in a foot, so it's 8/12 of a foot. And then you can take 8 divided by 12, and you get 2/3. I was thinking we could divide it, but we can't. So it's 2 2/3, or 3 times 2 is 6, 8/3. That doesn't make, yeah, 8/3. 3 times 2 is 6, plus 2 is 8. So we could use 8/3. You don't want to use a decimal because you shouldn't round until the very end. So plugging in, this is the length that goes in for L. So we have T equals 2 pi, the square root of 8/3 divided by 32. And plugging into our calculator, 2 pi square root 8/3 divided by 32. Now when you put in fractions, rule of thumb, always put them in parentheses so they stay together as a fraction. We get 1.8, and that was feet per second. So if the pendulum is 2 feet 8 inches long, it will take 1.8 feet per second. would be its time for a period. We have a second part to the problem. Using the same formula, how long would a pendulum have to be to have a period of 3 seconds? So to have a period of 3 seconds, we put 3 in for our time. This would just have, you would only have to use seconds here because it's time and time is in seconds. So on this one, it's 3 seconds. We're looking for L. When we're solving, just do one part at a time. So leave the square root and get rid of the 2 and the pi. To get rid of it, since we're multiplying, we would divide. So we have 3 over 2 pi equals the square root of L over 32. And then, when you have a square root, to get rid of it, you square both sides. So we have 3 over 2 pi equals L over 32. And then to squared. To get rid of the 32, we can multiply it on both sides. So we have 32 times 3 over 2 pi squared. That will tell us the length that we need. I'm plugging it in. Times 3 divided by 2 pi squared. So 32, and then in parentheses I have 3 divided by 2 pi squared. 7.3. 7.3 feet, because it was in feet. So if the pendulum is 7.3 feet, it will take 3 seconds for one period. Okay, section 4.4. How many droplets of water are in a river that is 200 kilometers long, 300 meters wide, by 30 meters deep? Assume a droplet is 1 milliliter and 1 liter is 1 cubic decimeter and 1 decimeter is a meter. 10 decimeters is a meter. So we have this, let's get to meters, and then we can change meters to decimeters. So remember, 200 kilometers. 1 kilometer is 1,000 meters. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 200,000 times 300 times 30. That will give us the volume of the water. Length times width times height. Now you can go 2 times 3 is 6 times 3 is 18, and then count your zeros. 1, 2, 3, 4, 5, 6, 7, 8. Thousand million, so 1.8 billion meters. Now, we know that 1 meter is 10 decimeters. So if we go 1, 8, 1, 2, 1, 2, 3, 1, 2, 3. And 1 meter is 10 decimeters. And then cubic decimeters is a liter. One Okay, so we need to make this cubic. Let's find this first. This is meters cubed. There we go. And so we need this to be cubic also, so that the meters cubed, because meters times meters times meters is meters cubed. And these will cancel. 10 cubed is 3 more zeros. So this is cubic decimeters. Three, 2, 3, 4. 1, 2, 3. Okay, just making sure we had it right. So that's cubic decimeters. And we know that 1 liter is a cubic decimeter, which means this is the same as a liter, because 1 liter is 1 cubic decimeter. So this is the same as this. And then we want to change it to milliliters. And we know that 1 liter if we look at our metrics, milli is 10 to the third, so it's also 1,000. So 1,000 milliliters is a liter. So we add 1, 2, 3, 4. 1, 2, 3, 4. 3 more droplets. Because we said a droplet is a milliliter, and this is milliliters. That's a lot of droplets. 1.8 times 10 to the 3, 6, 9, 12, 13, 14, 15. That's everything.